Bismillahirrahmanirrahim. So, dear students, today we'll be talking about another conformation that is of the molecule butane. So, it's a four carbon compound you can see here. This is the 3D structure of butane. So, today we'll be discussing these conformations through some 3D animation video, and also we'll try to see the animation of the energy profile. Fine. Okay. So let's move to our topic. So this is your butane molecule. You can see here we have four carbon atoms. So if we take this CC bond as the central one, means we'll try to see rotation across this bond. And then this methyl becomes one group attached to this carbon with two hydrogen atoms. So this becomes CH3 type system. Likely this carbon has two hydrogen atoms, so this becomes, we assume this as another group, so this becomes a CH3 type system. So then we'll try to keep one stationary and then rotate one carbon, and we know that the conformations, they arise because of rotation across CC single bond. Fine. So okay, let's begin. So the first conformation will arise, and that is the fully eclipsed conformation. So you can see here that this is the front carbon, and here there is a back carbon, and all these, they are eclipsed, superimposable, and same is the case with these these two methyl groups. Fine. This is called as the fully eclipsed conformation. So obviously the dihedral angle is 0. Fine. As this is fully eclipsed, so it has a lot of torsional strain, and it has some steric strain also because of these methyl bulkier groups. So it's highly energetic and less stable. Fine. So now what we'll do now, we'll rotate this front carbon slowly. Fine. And keep that back carbon fixed. So then we'll end up with another conformation you can see here. So you've done the rotation by this 60 degree. Rotated this carbon, and then you can see here where the methyl groups are now located in hydrogens. So this is called as the gauche conformation or skew conformation. Dihedral angle is 60 degree. Now in this case, you can see clearly the methyl groups have now moved apart, so that torsional strain has got reduced, steric strain has got reduced. So this is comparatively more stable than the fully eclipsed conformation. Now we'll rotate this front carbon further by 60. So when rotate this front carbon, now it will reach to this position. Fine. And look here. So now we have this hydrogen atom and the CH3 group with the eclipse. They are superimposable here also. So you have another eclipsed conformation, but we have the eclipsing between hydrogen and CH3. So they are eclipsed. So this is called as the eclipsed conformation, whereas this previous one, that's called a fully eclipsed, because now CH3 they are superimposed. But here we have CH3 hydrogen, that is the methyl group of one carbon, and hydrogen of other carbon. So it's called eclipsed conformation. The dihedral angle is 120, clearly 120. Fine. So this is called as the eclipsed conformation. This is also energetic. So this is less stable, but comparatively it's more stable in comparison to this fully eclipsed. Now if we rotate this further by another 60 degrees, so this CH3 group will come to this position, and you can see here this is the CH3 on the back carbon, and now this is the CH3 on the front carbon. So they are anti to each other, they are anti. Same is the case, these hydrogens are anti. So this is called as the anti conformation, and the dihedral angle is 180. Now this is the most stable conformation in the this is basically butane molecule. Fine. So let's take it here. This is butane. Butane molecule. So there's some typo error here. This is butane molecule. So this is the most stable conformation, less energetic. This is, if we take it 1. So this stability, it's followed by this Gauche conformation or skew. and then this is the third, and then finally this is the least stable. This is the order of stability. So now I'm going to show you all these by the 3D animation, so that will help you in better understanding. Fine. Okay, now look at this. This is your 3D picture of, this is CC bond, and this is one methyl group attached to this carbon. This is methyl group attached to this carbon, and these are the hydrogen atoms. So that will be sheet like this. Look at this, they are eclipsed. This is called as, this is your fully eclipsed conformation of butane molecule. Highly energetic. You can see it superimposed everything. Now, what I will do, I will rotate this front carbon by 60 degree. Fine. Let me do some rotation by 60 degree, frame wise. You can do clockwise also, you can do anti-clockwise also. Let me do like this. Look at this. So what I have done this rotation by 60 degree the anti-clockwise fashion. You can do this way also, fine. So this is the diagonal angle 60. Now the methyl groups are a little bit far apart. This is your skew conformation, or this is your Gauchy conformation. And then if you rotate it further by, let me go back. Rotate it further by 60 degree. Now look at what you are entering with now. Now we have hydrogen eclipsed with the CH3 now. So this is your eclipsed conformation. The first one was fully eclipsed. This is called eclipsed conformation, or you can say it's a partially eclipsed conformation. Fine. And then you do the rotation further. Rotate it further by 60 degree. And look at this, the methyl groups are now far apart. This is the most stable conformation called the NT conformation. Anti. Look at this. This is CC bond. We have done the rotation across the CC bond, and now these groups are far apart. So this is highly stable. It's called the anti conformation. Fine. So now I will show the video regarding the energy profile, how the energy of all these vary when we rotate. Okay, look at this. Now, you see this front carbon is rotating here. I'm going to show, this is your front carbon. This is rotating, and then accordingly the energy varies. Now you can see here this point, it is the maximum energy in this potential energy diagram. Now this is basically your fully eclipsed conformation. This one. Now that's your fully eclipsed conformation. We'll show it again. And this is the least energy here, so that is your anti-conformation. Fine. Now these wells, their energy is slightly above this, so they will come second in the order. So that's basically your Gauchy conformation. At these 2 points, they are partially eclipsed, and this is your fully eclipsed conformation. You see, just check the rotation of this bond and how the energy varies. Shoot again this video, beautiful video. So when this is in the anti position, this is the energy of the molecule. So when you rotate this front carbon, fine, so then you will achieve this conformation, then this conformation, then this conformation, and then this conformation, and then this. So these points again, these two, they are the least energetic, so that's your anti conformation. And then these points, they're also low energy but slightly more than anti. So that's basically your Gauchy conformation or skew conformation. And then followed by these 2 points, that indicates your eclipsed or partially eclipsed. And then this is your fully eclipsed conformation. Now this is the how energy varies. So this is all what we have today regarding this conformations of the butane molecule. So if you have any question, you are free to ask anytime. We'll be happy to answer you. You can write down your questions in the comments. So thank you.